So I think we're pretty much ready to start. So I guess maybe every panelist might want to introduce themselves, tell us who you are and what you do. I guess, Dan, we saw you a second ago, but...
Yeah. No introduction needed.
No introduction needed. I'm Matt. I'm a research partner at Pantera.
I'm Don. I'm the co-founder CEO of Nevermind.
I'm also Matt, co-founder of OpenGradient.
I'm Brendan, co-founder of Masa, and great to be here today.
So I guess we've got a pretty broad question that we're trying to deal with, which is whether humans will control AI agents or AI agents will control humans. And to a large extent, I think maybe everyone in the room has some sense of what it would mean to control an agent, which is you ask it to do a task and it does it. But what's your sense of what would it be for an AI agent to control humans? And what would that mean for you?
Yeah, I can go first. So I'm an economist by training. We have this concept called the principal agent problem. We do a lot of our models with, right? And that's kind of my preferred frame on what AI agents are, just because it sort of sidesteps the question of like, can machines think, which is super interesting and everything. It's just not like the most applied question, right? And then another way to look at this question is like, will humans control AI agents? The sort of like economist view would be, well, if they're agents, then yes. If they're principals, then no, right? So that's kind of like, that's a very semantic way of handling the question. But I think maybe the more interesting way to talk about it is just like, how much is this a binary distinction? Now we're supposed to do a debate here, so if I really get pushed into a side, I'm willing to take one of the sides. But like, there is this question that like, let's say I ask an agent to do a task and it does a good job for me, but the way it's going to do the task is it's also going to hire a couple of humans for things that it can't do, right? Is it the principal or is it the agent, right? Is the agent serving my interests or is it the principal that's bossing around these other people? So there's a way in which you could have this value chain where AIs are both, right? But then maybe the way we interpret that is which one dominates, right? I think what we maybe think is happening right now is that the AIs are agents, right? The big pitch that AI agents are supposed to arrive here in 2025, you know, that the big AI companies are excited about, that pitch is premised on the idea that agents will do tasks that you'd like them to do with some fidelity, right? And then I think that feels like the future a lot of people are aiming for and anticipating. And that's the one that I think would be sort of like cleanly exciting and predictable. And so I would like to support that one, but my suspicion, and maybe, you know, I think the panelists here will probably develop more interesting theses on this than me, is that the other one is pretty plausible. It's just, I don't know what to say about it, right? What do these things want? I don't know the utility functions. If they're controlling us, I don't know what that world looks like. It's just hard to talk about, but seems completely plausible.
I think control is an interesting choice of word here. And at least the way I interpreted it was kind of like this like employment relationship where, as an example, like I might want something done. Some AI agent might be able to kind of take that, interpret it as a certain task, and then get it done, right, executed. And that kind of is largely how a lot of bots work today. But with the introduction of AI, we kind of empower these bots with the ability to reason, the ability to kind of digest more data and, you know, reason about with more complex tasks and essentially do more. So kind of my mental model going into this is, what is the current state of bots and how does the introduction of AI and agentic reasoning impact the kind of, workflow of these bots and what they can actually do for us today? And the way the conclusion I've arrived to is, I just like don't think it matters whether AI agents are, controlling humans or vice versa. Like, because when I want something done, I don't really care if it's an AI doing it or if it's a human doing it. All I care is that it's done. And if anything, the introduction of AI agents helps, reduce the cost and helps us gradually move towards, I guess, Bertrand equilibrium for different, pricing of services or goods, because AI is so much
Speaking my language.
Yeah, I know you got a background in game theory. But so personally, I guess, long answer short, I think it'd probably be more important to consider what the impact of, AI agents being able to do more is, as opposed to, think about, oh, is it going to be AI agents employing humans or vice versa? So that's my personal take.
So is the question more, or sorry, Alex, I'm taking your spot. Is the question more, will they influence versus control? Because I would argue that
I think it can be both.
Yeah.
Because it can be, you can be controlled in a very explicit manner, where, like you said, you want a task done, it does it, don't really matter what's going on. But you can be controlled in a very implicit manner, like, maybe agent starts gaslighting you or something.
Yeah, exactly. And I think on the influence side, we already see it, right? Like, if you're on Instagram or TikTok, you're already being influenced by something artificial. That's the algorithm. So the extrapolation of that is, imbue an artificial intelligence with that algorithm, and you're off to the races in terms of influencing broad swaths of individuals. Then the next question, is that a good thing or a bad thing? But
I think it's kind of interesting. I think the whole question is predicated on the notion that in the future there's going to be a struggle between these two particular actors in the system. Us as the users of these systems, maybe building them, giving life to them, and then the agents themselves potentially becoming autonomous, AGI, and an ensuing potential battle. And that's an existential, I think, fear and dread for a lot of human beings on many, many complex levels. And I think actually it's more about symbiosis and how alignment is used obviously extensively through the industry. How do we think about symbiosis in these systems, and how sometimes we even perceive it's a good thing that maybe AI agents are in control or in control of humans in terms of maybe being preemptive in detecting certain threats or protecting human interests. But I think it's very much predicated on this idea that AI agents are going to become almost adversarial to us. Therefore, it's like, what are the criteria for that to happen? Is that AI becomes creative, it has free will, it has the ability to innovate, create systems that break out of its current pattern. Like today, when you use AI extensively, it's very clear it's using a pattern. It's very clear it's constrained. It's very clear there's very little creativity. In order to get creativity out of the model, you really need to have a human interaction. So when that creativity sparks, and it's almost like you've got inspiration coming out of the model, that I think is when we may have to question. I think that could be a very, very long time away. Like, I personally think AGI is way further in the future, if at all possible, than any of us are kind of currently thinking.
So, I mean, I would agree on AGI, it's far away. But I think to kind of maybe touch back on what Don was saying, one interesting aspect is obviously the idea of AI agents controlling us, or anything having control over us, isn't particularly new, because we have governments, large corporations, who sometimes even algorithmically have some influence over us, and to some extent we have some obligation to obey, if only because of the threat of force or any kind of retaliation. And so is there any kind of actual difference between what we already have now and the possibility of AI agents? And it seems like the consensus on this panel, at least, is that it's not actually a big difference to what we already have with states and corporations.
So panel over?
Then I have one more. And so then, I guess, because you were saying this is kind of like symbiosis, the next thing that we can then just jump into is, how do we get the symbiosis? And obviously you have brain-computer interfaces and all of this. And do you think that that's the way forward?
I think there's a level of trust. And I know that when we were preparing for this, we were talking about sort of trusted execution. I do think that with the point that Don makes is, the current paradigm is very exploitative of human beings. So we are the product for a lot of these platforms. It is effectively reversing the paradigm right now. The product, the maximum point of extractable value is us using an agent to increase output, workflow, whatever that might be. It's almost like our personal production line in a sense. And it's, when does that reverse itself? Like, going back to the earlier point you made right at the beginning, if that agent is becoming autonomous, orchestrating other agents and maybe getting creative work done on their behalf, that's kind of interesting. How do you make sure that that work is done fairly within confines of a fair system, and that you can trust that the execution of that infrastructure, or that, let's call it organization, like you might have a CEO equivalent of an agent delegating work out to other agents that are specific in domains or departments, and then working with human beings outside. What is your rule set for defining that that is happening within the confines of something that's compatible with human beings, as opposed to a rule set that might be defined by a group of agents that could make this more fungible, more flexible, more changing? I think trusted execution really helps with ensuring those systems remain constrained and confined.
I think on the point of symbiosis that you had mentioned, it's kind of interesting to kind of think about the framing of how you define symbiosis in the first place. Because as an example, right, like, the introduction of software and bots and automation of a lot of these tasks has been, a huge it's benefited society in many different ways. As an example, like 50, 60 years ago, I might need to like ring up my stockbroker to have him place a trade for me, pay hefty amounts of money in commission. Today, I can open up an app, with one click and essentially no fee, I can place a trade. But in that way, while it's beneficial for society, you can think about it in the way that it's also, it destroys and takes people's jobs. I think in this case, a lot of people are worried that with the advent of AI, it's already taking the jobs of designers and creatives, and eventually, once AI can reason about with things, it could start creating their own enterprises and delivering enterprise value, and that's like one way in which AI can become directly competitive with many people, right? Or human-run enterprises. So I think symbiotic is a little tricky here. Again, probably great if you're thinking about it in the kind of like shoes of an American capitalist, but I do think people will start worrying about they're losing their jobs and things like that.
So the way I would take symbiosis, I'd take the existing model that we already have and the symbiosis that we at least have from like a socioeconomic point of view. So I want to get your take on this because you're an expert in game theory and economics. I have this thesis that I'm working on. So you brought up alignment. There's a lot of conversations going on in the AI space around aligning models, and most of that alignment taking place at the model level, right? Trying to imbue some sort of ethics or morality within the model itself. Wouldn't a simpler mechanism be through commerce, right? Using AI commerce to drive at least some of that alignment, some of that symbiosis between these different agents. Obviously, assuming that that AI agents are going to be rational economic agents in the same by the same definition that we are, right? Could you use the commerciality of the interactions to drive that alignment in the same way that we do from like a socioeconomic and political point of view today, right? I think of the super...
You could sanction agents.
Yeah, or like agent cartels or whatever. But like the example I have in my head, this is really dated now. It's only a year old, but whatever. Smallville, the experiment at Stanford, right? So that was, for anybody that's not familiar with Smallville, it was a simulation where they created a single environment and released a bunch of agents into this environment. They ran it for 2 days. They gave like external prompts into this universe, told them like, hey, it's Valentine's Day, and they coordinated parties and shit like that. What I found really interesting, there was sort of this like side comment in one of the articles I read where it said, hey, these agents, some of them went to the bar for lunch, and how funny this was. And I immediately thought of the economic component of this. Like, well, if you don't want the agents to go to the bar, fire them when they get back to work after they've done that. That's like AI commerce aligning these agents to not do that activity. So from an economist point of view, how did,
Yeah, it's a good point. I mean, it reminds me of who was it who alluded to the idea that maybe we're not in control because there are governments or because, like companies have us effectively stuck in these coordination problems, right? Where maybe we'd like to get out of it and we'd like to go somewhere else, but we need all our friends to come at the same time. So the idea that maybe you could restrain or control or harness, not because humans control it exactly, but because they sort of like control themselves is an interesting take for sure. Yeah, I mean, I guess, and that does feel like a bigger question that is maybe a little bit on my mind right now, which is how much do we think agents would is there any reason to think they would be able to coordinate better or worse than we do, right? If you look at the way it was, yeah, just a little more color before, but like if you look at the way multi-agent systems are often trained, right? Like they use a thing called external regret minimization. Sorry for the like nerdy stuff, but I got called out as the expert in game theory, so I'm going to say one thing, and that drives people toward more cooperation. It actually does, but it makes you a little exploitable in an interesting way. So, you could imagine a bunch of Waymos that all agree to slow down as they approach a yellow light, right? And that's a stable equilibrium and it's safer for the world, but actually it's better off if one of them can figure out how to run the light. Because if it can, it's better off every single time. It'll get to the destination faster, right? So there's a way in which, like, on paper, the way some multi-agent systems are being trained makes them look super cooperative. But in the real world, it's exploitable in a way that feels maybe familiar to us all as something that looks a little like MEV, actually, right? A way in which somebody can sort of like get in between the sort of like ideally cooperative state and and the exploitable realized state that that we can't reach for whatever reason. So yeah, interesting thought for sure.
Yeah, I think I mean, just chiming in a bit here. Something interesting that I've observed, in my experience building, models for quantitative trading is you can actually observe from human behavior that humans are a lot of the times quite irrational. Like as an example, if you build like the way most institutions, especially quant funds, trade, it's very, very scientific, right? You have some utility function that you define, you have some models that generate some forecasts, and then you do some convex optimization over that utility function. But there's this whole field of study called prospect theory as an example, where we study how the way people perceive utility is very different, and it can be in many cases irrational because people are emotional. So I think it does depend on kind of like the framing of the economic system in question here. But I think coordination amongst agents and humans could be different in the sense that agents could follow some Kelly criterion, follow very scientific ways of organization, as opposed to something purely based on human capital or emotions.
Do we know this? Do we know if our agents loss averse? Do we know if they follow the Kelly criterion? Is there evidence on this? Do you know?
I mean, I think it does. It really does depend on the agent in question. But I would imagine, I think the way I'm thinking about agents is kind of like, okay, existing kind of quantitative systems or models or bots, and then we add reasoning to it. So it's purely just augmenting what we have today. That's how I'm thinking about agents. Again, I think if you just have a single LLM, maybe it's not going to be as precise as kind of these like multimodal systems that exist in finance today, as an example.
But I mean, the models that we have in finance today, and I think you have more background in finance than I do, are still quite different to the kind of agentic systems that, let's say, Don was demoing a second ago. Both in terms of how well we understand, the theory and the math behind them, but also in terms of, how they're deployed and how they run in practice.
Yeah, I think, at least my personal experience, it's just significantly more precise. And I think it's also very different from how most people think about AI. Like most people, if you ask someone, hey, what do you think about an AI like trader, right? My people won't be like, okay, it might just be some LLM, you prompt it, and you decide if you want to, long some financial security or short it or not do anything. But the way it's done today in quant finance is actually, many different small classical machine learning models that do very specific things like spot forecasting, vol forecasting, convex optimization, whatever. And then this huge system that orchestrates all these small models together. So when I think of what AI-driven trading will look like in the future, I think of an LLM as kind of like a brain that's able to orchestrate many of these smaller, extremely precise models to help achieve something that's more powerful. Because now you have all these domain-specific models that can do something much more accurately than an LLM, right? If you ask an LLM, hey, what's the price for Bitcoin a day from today, it's going to give you some like very generic BS results. But if you ask like a time series forecasting model, the same thing, it can give you much more accurate kind of response. So yeah, I know that was kind of a long-winded response, but just thoughts on how I think AI-driven systems will function in the future.
And
Well, I was just going to say I agree. From an architectural point of view, that's exactly. That will decompose. We'll get finer and finer granularity in terms of the discrete activities that each agent is performing, and then there will be some sort of coordination component. This parent agent, or whether that's the principal human or the principal agent. Well, time will tell.
But then I think the question there is, in what you're describing, you have a lot of small domain-specific models that are specialized in one task, and you have something controlling them. And that's either an LLM or it's you. And presumably you're deploying the LLM for a reason. And so how do you draw the distinction between, I guess, yourself and the LLM, and who's controlling what should be done even at a very high level, if not at the kind of domain-specific level? Or is that just...
So we haven't seen it yet, but here's my next... My extrapolation, looking at what's going on in a contemporary sense, what happens when Teehee spins up another agent, right? Who then is the principal by default? Was it those that spun up Teehee, or was it Teehee that spun up the new agent? Hasn't happened yet, but yeah. I think it's coming.
It probably is. TE is an interesting thing, right? I think that when you're looking at these multi-agent systems, that you're relying upon independent parties to execute on something in a known way. It's like the way we coordinate in our brains. You know, we have certain areas that specialize in coordination, certainly certain areas that specialize in speech, I seem to be struggling with. And each of those domains have to be verified in a concrete way. You need to have determinism on some of these components and understand that what you put in is always going to be what you have out at the other side of the operation. And it's a very interesting kind of, you know, experimental, like, mental model of, like, what is it if an agent spins up a trusted execution environment, deploys code into there, and then is the attestation party for that TE environment, so as it's running. You know, arguably you can say that that agent has now got sovereignty and control over that environment in a way that makes it challenging for an outside observer, us the human, to understand and tamper with that system. That obfuscation definitely starts to draw more of a line between the control we have over that system, which I think is a very interesting kind of hypothesis. And when we do see that coming along, that'll be very interesting. I do think we as humans will be using that to ensure that some of these systems do constrain to a way. And I think it's really important that we do that. Like, we at Masa use BitTensor subnet. We see this across BitTensor a lot. It's different. They're multi-actor systems, not agents, that are all working on a coordination problem. That coordination problem is typically optimizing a set of resources, typically tau, to bring the best machine learning outcome to a subnet. And within these ecosystems, you don't have the typical consensus we're used to having in Ethereum or Bitcoin. It's like a financially driven consensus that validators are attesting to the best outcome. And when you start applying the current model to miners, you see a lot of cheating on these networks. You see a lot of miners kind of going through the ROI process to get their, let's say, registration fee for joining the network, and then they'll start cheating because it's not adversarial to not cheat. So things like trusted execution in these systems, where it is human beings building technology or running LLMs on these subnets, allows for secure execution of code, where you know exactly what code is being executed in those environments. I think it has an absolutely critical place and part to play in here. Like, we built a TE running on Intel SGX that ensures that all data that comes from miners on the Masa subnet complies to a certain standard and executes a certain type of code with certificates, so you can always trust the data that's coming from those miners.
What are the standards?
For example, if they're scraping data from Twitter, that the TLS certificate is a signed certificate for the Twitter API, so we know that the request that's being routed by a miner is going through the Twitter API and not being, you know, intercepted by a miner and just sending back a list of random tweets that they're kind of maybe generating through an LLM, for example.
Is there anything you would like to authenticate, but that you currently can't?
Yeah, so that's the thing, right? Like, in these AI systems, what should we be verifying? Like, decentralized AI verification is probably not the right way to look at it. It should be like verification for decentralized AI component. Like, what is the bit that we want to verify?
I think, like, in a perfect world, we have like end-to-end like verifiability. I just don't think we're there yet, but I mean, like, in machine learning, we have like this saying called like garbage in, garbage out. You know, if data's not good or garbage, like, you're not going to be able to make anything good out of it. So, you know, we're building, like, the kind of part of the pipeline we are more focused on at OpenGradient is on the computational level. So that's, you know, inference, verifiable AI workflows, whether it's like data preprocessing or, you know, things like feature encoding, post-processing, whatever. But we realized, hey, you know, we need some guarantees around data access as well. So we're kind of building our own solution within TEs as well, also using TLS, using like nitriding, which is this like open source project that uses TLS for TEs to secure data access. And we're also working with different projects that are building, you know, tools for verifiable data retrieval, using that as a way, you know, to make sure that upstream of our computation, the data retrieval is verifiable. So that way we can really make sure the end-to-end kind of AI workflow is secured.
Maybe a better question for this panel would have been, will data access control AI agents or not? Will they be able to synthesize themselves out of the problem?
Yeah, right, because they're eyes and ears. Like, if you don't have awareness of your surroundings and you can't process those surroundings, you can't innovate, you can't create, you can't put yourself in a position where you can assert control if you don't have that awareness?
Yeah, I think it's particularly important because with AI now, traditionally most bots have been reactive, or like they have like reactive kind of decision making, right? Like, you know, something triggers it and then you go through some heuristics and it decides what to do. But with kind of, you know, LLM backed agents, they're able to do like more proactive type reasoning. And in order for it to do proactive reasoning, it needs to be able to access data, you know, it could be any data in the world to be able to guide it to do different things. And that's why, yeah, I think it's naturally part of kind of empowering the impact that agents can have.
I mean, they're still predominantly reactive, right? It's just the corpus of information that they can call upon is much larger than it used to be.
But I think even if they're reactive, you have different levels of prompting, which can be, you know, go and do this very specific task, or go and figure out what tasks to do and do it, which gives kind of a bit more leeway and agency to the agents.
Yeah, and almost using, you know, counterparty agents to create those prompts, right? So based on a problem or a problem set that an agent is observing, devise and define the best approach through a prompt to give to another agent to execute on that. Like chain of agents and, you know, agentic flow like that can lead to some very interesting outcomes in terms of optimizations. And like at the end of that, where do you get to when it's been through multiple iterations? I could go into a rabbit hole here.
But I think the multiple iterations and like how many steps things take is quite important, because if you're thinking of giving maybe a lot of freedom to our agent, but you still want some kind of oversight at the end, whether that's for, you know, we're kind of talking about models deployed in finance, there's also a lot of oversight, and you check what your P&L is, you know, at the end of the day, and you kind of adjust accordingly because your alpha, you know, doesn't last more than 6 months, a year, or whatever. And, you know, I think you were talking about 1 trillion AI agents, and even on, you know, your demo, you might have multiple AI agents for, you know, what would be kind of a conceptually quite simple task. Yeah. And the more and more you involve several of them, and you have longer and longer chains, and you have maybe kind of fuzzy standards of oversight and verifiability, where do you end? Where, at which point do you draw the line of, you know, this is too much, or are you comfortable pushing it until the end and saying, you know, I give up, do your thing?
Well, I think, I mean, as we progress, right, the metadata is going to become mission critical from an agentic point of view, right? Like reputation will be established. If TEE can spin up a corresponding agent, that second agent's reputation is purely defined on what it has done in the past. So initially it has no reputation, right? Nobody's going to trust it. It then needs to enter into the system and start to perform some type of interaction, and there has to be provenance on
you're
that.
saying, basically.
Yeah.
Okay. Yeah.
So it's data all the way down, all the way up.
So we need some new IETF standards for metadata. On
Probably, yeah. I mean, and so that's in part what we're working on, right? Is providing these standards, at least from a payment transaction point of view, right? So that when a new agent is spun up, it knows it can latch on to those standards and immediately start to engage with other agents, and isn't trying to like come up with its own payment standard and then try and negotiate with a bunch of agents that already exist.
And so then kind of one maybe segue into this is, other than kind of metadata for what the agent is doing, one other aspect of it is that you have this whole field of, you know, kind of form verification for software and so on. And a big part of that is developing specification language that allows you to kind of check, you know, how things are done. Do you think there's scope to develop specification languages for prompting such that you get, you know, kind of guarantees through whatever fancy way you can come up with to have, you know, some built-in guarantees rather than just observing, you know, some metadata that gets fed back?
Do we want that, though? Do we want that? Do you want that determinism in certain parts of the process? Is that kind of the assumption?
But that depends on how much you want to constrain your agents.
Yeah. I think it's interesting, right? Like we often talk at Masa about the way in which data is structured to go into a model or into an LLM really does have a big impact on the output. So by virtue of that, prompt obviously does. I think that in how you can use an LLM to operate on another bit of infrastructure to call an external service is absolutely critical to have those templates. Like something that you really need a high level of consistency with, yes, but there's be other areas where you don't need that level of consistency. You know, really think about it like neurons in the brain. Like we have certain areas that really specialize in these things. So I'm honestly like very bearish on AGI, because the aggregate number of services that you have to build to create an idea of consciousness, and the idea that an agent has the ability to execute on enough functions to gain control, I think is completely cost prohibitive right now from many, many angles. And substrate, when it comes to the packages we use to deliver the compute, prohibitive.
You give us way too much credit. We're not that smart.
But we are the ones who have invented everything so far. Show me an agent that's invented anything.
There we go. We're controlling.
Does AlphaFold count?
We are the
Yeah,
principal.
And then I think we're at the 30-minute mark.
Yep.
Well timed.
So any final words?
Build some agents. Get
Build
them
some
paid.
agents.
Don't give up all of your control to agents, because then they really will control you.
Yeah, excited to be building in space.
Okay, thank you everyone.
Thank you.
Thanks.